Good morning. So, here's where we left off last time. And you see we have a line function that can only really draw lines down in this. It's like 1/8 of the screen, which will be just fine 1/8 of the time. Today we're going to fix that. So, we began implementing Bresenham's line algorithm from this little bit of pseudocode. And if you come back up to our program, you can see the pseudocode is represented down here. And I wanted to point out the very next section, the Wikipedia article. As mentioned above, this only works in octant 0. So, octant 1/8. We implemented 1/8 of the algorithm. So let's go through and implement the rest of it. So, just going to scan through this a little bit to see what we're missing. Because yeah, I was struggling with going from the min x to the max x, and really this one is only designed to work where the slope of x and y, x and y are both 1, or positive numbers. One or the other. So let's scan through this a little bit, see what we need to do. Complete solution. It's promising. This looks familiar. I think I've actually implemented this before. Well, this version of the function. So, it says it's designed to perform all the octant line draws. That's promising. Let's come back here and replace our function with this new function. Gotta update our variable names. Then the absolute value function, I think, is math.abs. Wrap that in parentheses and place the n while with the closing curly bracket. Plot is set pixel. d2 is greater than or equal to dy. That takes the next 3 lines. Well, until the end if. So grab that. Okay, so according to the pseudocode at least, this is supposed to handle all of the octants. And technically, we don't need the min-x and the max-x for this because it's controlling which direction it goes based off the xx and sy, and then using the while loop to keep walking down the line until it reaches the end. Let's see what it looks like. Oh, that looks like an error. There's always an error. dx is end. So we're not in Python, we need to actually tell what kind of thing we're working with. Okay, what else did we miss? It's pretty bad when you know there's an error, but it's not throwing an error message. What I'm thinking happened is that it got stuck in this while loop. So we check our work. Semicolons aren't really necessary in JavaScript, but they make me feel better. Well, let's see. If I can't make this work, we can always go up to this other version of the plot line. Would not be the end of the world. Just walking through this line by line. Well, it looks right, but something's wrong. So, let me load up another thing here. I have an idea. Because I know I've done this before. I was working on a C++ project that was also implementing some low-level graphics algorithms like this one. There it is. So this thing worked when I implemented it. Let's see if we can take advantage of some code that I've already written. Convert it from C++ into JavaScript. Shouldn't be too much of a stretch. Code looks very similar to what we already had. Let's do a little comparison. One of the things I'm seeing is that it's not taking the absolute value here. Well, it kind of is. That's what that does. If the x is less than 0, then you negate it, so that's effectively an absolute value. The break is missing here, which is interesting. Where it says if x0 goes x1 then break, the same thing here. Well, let's see what it does. That's still not working. That is interesting. I really thought that would work. Theoretically, this bottom section is all we really need in order to draw a line. I know for sure if it's getting stuck in here. Ooh, yeah, that's breaking down the menu. Okay, something terrible is happening inside that loop. Now, we gotta figure out what is the deal. Is it something funny about JavaScript that's keeping this from being able to finish? It's not breaking until that is true. There shouldn't be any kind of weird floating point math going on. Let's throw in some logs. That's mysterious. It should have at least gotten down that far. where's the malfunction? It works if we comment out the draw line. All right. See if that works. Kind of. Are there things we're drawing are missing? Oh, right, because everything is coming through here and we're not drawing this stuff anymore. So it's reaching draw line 2. Got that far. Can we get this far, where it logs the values we calculate? So those are all the numbers, and the problem I'm seeing here is that we have some floating point values that, oh, because of how we are. So I think what's happening here is that when you do math with floating point numbers, the ability to test for sure if two values are equal becomes a little bit sketchy. Because it's just a thing about how computers do floating point math. You can tell if two floating point values get really, really close, which is usually the better case, but knowing that they're equal it can get weird. But the solution, we're drawing in pixels. So we actually need to floor all of the incoming numbers like this. And hopefully this will work. Let's just see what happens. Oh, we have a line function. Well, that's super exciting. If you can draw a line that sweeps through all 360 degrees, then you're probably pretty safe. Let's clean this up just a little bit. And I'm going to put these brakes back in because early exiting, if the algorithm thinks that's a good idea, then maybe it is. right, let's see what we got. And there you go. I like to rewrite this loop. Like at one point we were basing the angle on the total time. So let's stick that back in there because I kind of liked that. Let's see. I think there's something like that. And is that getting faster? That is getting faster. Okay. I'm not sure the input value is delta time. I don't know. I think it's supposed to be. But let's log this. What is delta time? You can see it logging the time on each click is actually really slow. Yeah, that's not delta time. That's counting up forever. That is the total time that's coming in. But hey, that means we don't need to do the extra math. It also means that this is probably wrong. But, oop, broke something. What did I break? Delta time is not defined. Well, yeah, because I just removed it. Now that's still running slow because I'm still logging the time on every frame. That's definitely not a delta. Which, you know, I knew that at some point because that's what's going on here. This is calculating the delta time since the last update. But we're just going to rename that to total time to make things perfectly clear. So that I don't come back to this in 3 months and wonder what does that time variable even mean. And now, let's see what we got. Now why is it slow? Oh, it's running slow because I need to not divide this by so much. I think that's the only thing. It's writing out update once a second. That's good. And you know, it's sweeping through the circle at a leisurely pace. To be a little less leisurely, let's make it run twice as fast. No, let me get run a lot faster than that. And I don't know, I'm just kind of messing now. Okay. You know, that feels right. So, next time we talk, we're going to implement Bresenham's circle algorithm and read all the pseudocode and examples next time so we don't get stuck like this. Although, with circles, it's actually super obvious that there's 8 octants. I don't know. It just is. So, that's it for this time. Thanks for watching.